Okay, we're given phone calls arrive at the rate of 72 per hour at a reservation desk, and we want to compute the probability of receiving 3 calls in a 5-minute interval. So a lot of times when you have a particular interval, the probability of a success is very, very low. You could use a binomial to approximate, but we use the Poisson distribution. So to do this, looking at the formula over here, I see a lambda. Okay, so that's lambda, which would be my expected value, my mean. And in this case, it would be, I would expect 72 within a 5-minute, so 72 hour within a 5-minute interval. So I have to convert my minutes to hours, so I have the same units. All right, and so then I'm asked the probability of receiving 3. So that's the value of my random variable. E is just the number E on your keyboard. But what you can do with Excel is there is actually a Poisson.dist. Open a parentheses. It's asking you for X. It's asking you for the mean. And just as I showed on binomials, we don't want to accumulate, because if I said true, that would add up 0, 1, 2, and 3. I just want the probability of exactly 3, and I get my answer. All right, so notice the next one here. We're pretty much doing the same thing, but now in this case, my lambda is based off of 15 minutes. So 72 times 15 over 60. And what this number is what you would expect. Okay, this is the total number you would actually expect. It says exactly 10 calls, so I change that to 10. And then I do my formula, once again, which you could have just changed the numbers up above and did this once, but I just want to show it written out. And then the mean, and then, then of course, false. So I get this probability. All right, so all of these, it wants you to round properly like that. All right, so the next one says, suppose there are no calls currently on hold. If it takes the agent 5 minutes to complete the current call, how many callers would you expect? Remember, the mean lambda is your expected value. Well, it's in this case, it's once again 72 times 5 over 60, which is what we got up above. So that's what we would expect to get. Then it says find the probability none would be waiting. I could just go up there and change that to 0, but I'll go ahead and do this for each one of these. So equals Poisson.dist, my X for none, my mean, and then false to get my actual probability. All right, the last one. If no calls are currently being processed, what's the probability that the agent can take 3 minutes for personal time? So we need to figure out that 3 minutes related to, I guess I'll be consistent here, are what we would expect, our average time. So 72 times 3 over 60. And then based on here, without being interrupted by a call, that would mean no calls, right? And so that would be my Poisson.dist, my X, no calls, my what I would expect while I'm on break, and then false to get my final answer. So once you figure out this part, how to find lambda, okay, because that's a lot of times you have to actually find it, then you just actually use the Poisson.dist formula in Excel, and away you go.